everyone, this is your math guru. In this video, I'm going to show you how to solve the following revision questions on powers and roots. Please don't forget to click on the like and subscribe button below for more easy to understand math concept. The first question says, simplify fully without using a calculator 3 to the power of m plus 4 minus 6 times 3 to the power of m plus 1 divided by 7 times 3 to the power of m plus 2. In order to solve this exponential expression, I start by splitting up each of the terms. That way, it's easy to identify the common term at the top and at the bottom. So I have this separated as 3 to the power of m times 3 to the power of 4. I'm applying the exponential law in the reverse, minus 6 times 3 to the power of m times 3 to the power of 1 divided by 7 times 3 to the power of m times 3 to the power of 2. What I've done is, if I have two terms multiplying each other and the base are the same, then what I get to do is to add up the base. So if you look at each of the terms now, it's easy to identify the common term, which is 3 to the power of m. That is common to each of the terms. So therefore, simplifying further, I'm going to factor out 3 to the power of m at the top. I'm left with 3 to the power of 4 minus 6 times 3 divided by, I'm also going to factor out the same term at the bottom, that's 3 to the power of m. I'm left with 7 times 3 to the power of 2. If I simplify further, I have 3 to the power of m is common at the top and at the bottom. So if I divide, I'm left with 3 to the power of 4, that's 81, minus 6 times 3, 18, divided by 7 times 3 squared, that's 7 times 9, that's 63. That's equal to 63 divided by 63, and my final answer will be 1. So if I simplify the first question, my answer will be 1. And the second part of the question, it says solve for x without using a calculator. I start with the first one, it's 2.2.1. It says x to the power of negative 3 over 4 equals to 8. In order to get rid of the exponent, I'm going to multiply by the negative inverse. So what that means is, if I raise x to the power of negative 3 over 4, I'm going to raise that to negative 4 over 3. Note that I'm trying to look for the inverse that will make the power of x positive 1. And whatever you do on your left, you also do on your right. So I'm also going to raise the right hand side to negative 4 over 3. If I multiply out the powers here, negative 3 over 4 times negative 4 over 3 will give you 1. I'm left with x to the power of 1 equals 8 to the power of negative 4 over 3. For rational exponent, if I have a to the power of x over y, the a at the top will be my power or my exponent. The y at the bottom will be my root. Likewise, if I have a to the power of a negative exponent, to make it positive, the negative will become my fraction bar, and then it's going to be a to the power of positive m. So I'm going to apply these two rules to a to the power of negative 4 over 3. So I start by making it positive. That will be 1 over a to the power of 4 over 3. And if I rewrite that using my surd, that will be 1 over the bottom, which is the denominator 3, will be my root. So it will be my cube root of 8, and then all raised to the power of 4. X equals 1 over cube root of 8 is 2, then to the power of 4. Therefore, my final answer, x, will be 1 over 2 to the power of 4, 16. So therefore, for the next question, the value of x is equal to 1 over 16. For question 2.2.2, I have the equation, exponential equation 4 to the power of x minus 2 to the power of x equals to 2. Moving all the terms to one side, I have 4 to the power of x minus 2 to the power of x minus 2 equals to 0. I'm going to apply what I call the K method, and to get to the K method, I start by splitting up my 4 to the power of x. In exponential form, that will be 2 to the power of x all to the power of 2, because 2 squared is also equal to 4 minus 2 to the power of x minus 2 equals to 0. Note that I can identify the common term 2 to the power of x. So I have let k equals 2 to the power of x. Like I mentioned earlier, I'm using the K method, so my equation becomes a trinomial, k squared, or a quadratic equation, minus k minus 2 equals to 0. If I solve, I have that is k minus 2 multiplying k plus 1, and that will be k minus 2 equals to 0, or k plus 1 equals to 0. I start with the left hand side. K will be equal to 2, and remember we have a k equals 2 to the power of x, so I change my k to 2 to the power of x equals 2, which has an invisible 1 as shown. Therefore, my x is equal to 1, or I'm going to solve the right hand side. K will be equal to negative 1. K is 2 to the power of x equals to negative 1. I can't have a negative number, so therefore 2 to the power of x cannot be equal to negative 1. So for the second answer, 2.2.2, I have 2x equals to 1, because x cannot be equal to negative 1. For the third part of the question, I have if x equals 3 minus root a over root 2 and y equals 4 plus root a over root 2, determine the value of x plus y all to the power of 2. So, by substituting, I have x equals 3 minus root a over root 2, and I have y equals 4 plus root a over root 2. Therefore, to find the value of x plus y to the power of 2, I'm going to substitute. That will be x is 3 minus root of a over root 2 plus I have y 4 plus root of 9 or root of a. I'm going to change that. It's a not 9 divided by root of 2 all to the power of 2. I have two options. It's either I expand the bracket by foiling, or I can solve the contents of the bracket first. I'm going to opt for the second option, that is solve the content of the bracket first. So I have that raised to the power of 2, and because the denominators are the same, I'm going to place them under the same denominator, root 2, and then for my numerator, I have 3 minus root a plus 4 plus root of a. Note that minus root a plus root a cancels out. I'm left with 3 plus 4, which is 7, over root of 2, all squared. Therefore, x plus y all squared will be 7 squared, that's 49, divided by root 2 all squared, that's 2. I can simplify further and write it as a mixed number, that's 24 1 over 2. And for the final part of the question that says, show without a calculator that the 12th root of 10 times 6th root of 640 times the 4th root of 810 times the square root of 40 is equal to 120. So I have on my left hand side 12th root of 10 times the 6th root of 640 times the 4th root of 810 times root of 40 equals 120. So I'm going to be proving from my left hand side. I have my left hand side and my right hand side. So I have from my left hand side, I will first of all start by splitting up the value under my root. So I have 12 of root of 10. I'm going to rewrite that because it's not 12 times root 10, it's the 12th root of 10 times the 6th root of, to change 64 will be 2 to the power of 6 times 10. I have times, I'm going to change 810. 810 will be the 4th root of 3 to the power of 4 times 10 times the square root of 2 squared times 10. That way it's easier for me to change my surd form into index form. And changing my surd form to index form, I have 10 to the power of 1 over 2 times, my dot means multiplication, I have 2 to the power of 6 over 6 times 10 to the power of 1 over 6 times 3 to the power of 4 over 4. Note that the powers under the surd sign is being divided by the root. So I have 1 over 4 times 2 to the power of 2 over 2 times 10 to the power of 1 over 2. If I simplify further, I'm going to start by grouping all the terms that have a base of 10. And because the base are the same, I'm going to add the powers, which will be, that's 12, that's 1 over 12, plus 1 over 6, plus 1 over 4, plus half, times 2 times 3. I'm going to use the same dot to denote multiplication, times 3 times 2. The value, if I add up all the fraction, it will give me 1. So I have 10 to the power of 1 times 2 times 3, 6 times 2, 12. Therefore, my answer will be 120. So because the question says we should show without the use of a calculator, I've been able to prove that my left-hand side is equal to my right-hand side, which is equal to 120. Thanks for watching. Bye.